Okay, so let's look at a couple of things here. So, greatest common factor. Yes. You betcha. Help yourself, come right up. Okay, greatest common factor, right? So we want to do, yes, sir. What's that? Okay, what's it gonna be? Negative 8x. Good, good. And so the part that people typically see, we have numbers in both terms and variables, right? So we want, why don't you guys go ahead and, I think I'd click these closed. Click them closed and just take a quick look if you're part of the review up here. So the 8 makes sense, because 8 divides into 8 and 24. Most people are fine with that, but the part that people tend to miss is this negative, right? And we have to include the negative because that's the leading term. It's the term with the biggest power of x, right? So we need to have the negative there. And now notice that each of these terms has an x in it. So then we have to just ask ourselves, how much can we undistribute? Well, I can only undistribute an x, right? Because that's all this one has to give. This one has an x times x, but this one only has an x, right? The smallest power of x that shows up in each of the terms that has that variable is the only one that I can undistribute. So I end up with negative 8x, okay? Now, if I were gonna, so that's the answer. If I were gonna factor this, if I said something different, like just factor this, well then I would have taken my negative, or my GCF out, and what would that have left me with? It would have left me with x plus 3. Good. Okay, and once again, this is the answer they're looking for, right there. But it helps us to see this. How do we know that there's nothing else for us to undistribute? Well, because look what's left behind, x plus 3. There's nothing I could take out of that, right? So I know I'm done if I end up with an x plus 3. This one doesn't have a variable, so I can't take out any more x's. And there's no number that goes into 1 and 3, right? So we know we're done because there's nothing else to undistribute. Okay? Questions? You good? Okay. What about this one? Completely factor, and we're going to write it in fully factored form, right? Okay. So what do we always want to try to do first? Greatest common factor. Yeah, we always, when we're factoring stuff, we always want to see if there's a GCF we can undistribute. But there isn't, right? There's no number other than 1 that goes into 49 and 81. And the 81 term has no variable, so there's nothing to undistribute. So then what? Okay, so then we're asking ourselves, what else can we do? Well, there's some, say it again. So there's a couple things we can look at here that sort of give the answer away. One of them is, look, we've got an x squared term, right, in the first term, and then we've got a minus a number. If I have something, some pattern of the form x squared minus a number, then we have to ask ourselves, does this thing fit the pattern a squared minus b squared? Because that's there's a pattern that goes with that, the difference of squares pattern. If something's in the form a squared minus b squared, where a and b are just whatever, right? Something squared minus something squared, then that's going to fit the pattern a plus b times a minus b. So the question is, can I write this as a squared minus b squared? Okay, so the 9 makes sense, right? Because 9 squared equals 81. But the other one's a little bit tricky. Okay, good, because whatever I put in these parentheses, when I square it, I have to get that whole thing. So it's going to be a 7x, isn't it? Right? Because 7x times 7x is 49x squared. Okay? So now I know what my a is and I know what my b is. And so the answer is just going to look like a, which is 7x, right, plus b, which is 9, times a minus b. And I'm done. And I know I'm done because if I look at both of those factors, there's nothing else I can do, right? Make sense? Okay? So compare that to this one. Now, what do I always want to do first? Okay, GCF, right? So is there a GCF? Okay, minus 2, right? So I can undistribute a minus 2. What am I left with if I do that? Everybody agree? Okay. So can I go any further? Well, a lot of times people are tempted to say, well, yeah, I can. Look, that's a pattern, okay? Because 3 squared is 9. So it looks like the pattern x squared plus 3 squared, but that's not a pattern, right? The sum of squares is no pattern. A squared plus b squared, we're stuck with. We can't break it apart, okay? So because that's the only pattern that it would fit, which is a non-pattern, we can't go any further, right? Because of that plus sign in the middle, okay? See the difference? Now let's look at, I want to compare that to a couple other really quick ones. What if I asked you to do this one? What if we go back to this previous page? What if I had one that was negative 8x squared minus, oops, that's wrong. That's the wrong one. Let's do this one. What if I had one that was 49x squared minus 81x? Different problem. I can take out an x, right? That's a super easy one. I could undistribute an x, which is going to leave me with, no, 49x, right? Because I'm just dividing each of these by x to see what I get. Well, 49x squared divided by x is 49x. What's 81x divided by x? There you go. Can I go any further with that? No, I can't, because that's just an x, right? It's not an x squared. This isn't a difference of squares now. I don't have 49x squared. I have 49x minus 81. There's no GCF. Look, this one doesn't have an x. Nothing goes into 49 and 81, so I'd be done there, right? You see the difference? The difference is this one didn't start off as an x squared term minus a number. It started off as an x squared term minus an x term, right? So that's an easy one, okay? What about this guy? Yeah, I gotta make it on one side though. So I'm gonna push everything to the left. I'm gonna add 5x and subtract 210, right? So if I do all that stuff, if I move him over there, I'm gonna add 5x to both sides. I'm gonna subtract 210 over to this side. Look what I get then. I'm gonna get 5x squared plus 5x minus 240 minus 210 is minus 450. And the whole thing is equal to 0, right? Okay, now what? So the first step is I gotta get it equal to 0, right? Good, we can factor it. We can factor it. It tells us we wanna do that. We're gonna factor and use the zero product property, right? So what's the first thing I can factor? 5, good, we'll take out a GCF. So we get 5 times what's left behind if I take out a 5. Good. We're going to get x squared plus x minus 45, or 450 divided by 5. No? Well, 90, there you go. Okay, and that whole thing is equal to 0, right? Okay, so now can I go any further?
Can you undistribute those?
Okay, right, well, the 5 we're done with, right? We factored that out, but the question is, can we break this up some more? Yes, sir.
Can we distribute those x's out, or do anything with those?
With the x's?
Yeah.
No, we can't really, right? Because we got a trinomial here, so we want to see if this fits, if we can factor this using magic numbers, right? So if this thing is going to break apart, that's an x squared. So we know those would both have to be x's. That 5, that's just hanging out front. We already got that. We already pulled that one out front. There you go. Good. So we have to multiply to negative 90 and add to 1. So plus 10 minus 9. Good. Okay. Equals 0. And then now we got it all factored. Now we use the zero product property. So we know that the product of the factors is 0 when I multiply by 0. So when the factors are 0, right? Well, 5's never 0. 5's 5. But the other ones, we could get some solutions. When is x plus 10 equal to 0? There you go, so negative 10. Okay. Or positive 9. Those are my two solutions. Okay? How could we check? Go back to the original equation and plug it in and see if we get a true statement for both of those. Yeah. Okay, now this says we want to write this in, we're going to factor this. We want to write it in fully factored form. So that means when I'm done, if I multiply everything out, it's going to give me this back, right? What do we try to do first?
GCF.
GCF, is there one?
No.
No, there's not. So this one, yeah, this is one where we're stuck with A equaling 2. So this is a little tougher one to factor. What's our trick for this one? Slip and slide. Good, and we know it's slip and slide because I can't factor that out. I'm stuck with that 2. So I'm gonna slip it to the end, right? That's step 1. So I get x squared minus x minus 3 times 2, which is 6. Okay, now what? What's the word we use for that? What are we gonna do to this? Okay, so that's factoring, right? We're gonna break it apart into product of factors. So the word we use in math is we're gonna factor it. That's the verb. So those have to be x's. What do the magic numbers have to do? Okay, multiply to c, which is negative 6, and add to negative 1, right? So Mackenzie, what do you get for those?
Plus, and then minus.
Okay, good. What would those numbers be? They're gonna multiply to negative 6 and add to negative 1. What do you think, Tony?
Negative 3 plus 2.
There you go. Okay, good. And then, so now we're on to step 3 of slip and slide. Okay, good. So we're gonna divide by, what was the number that we slipped? Well, that was a 2. Yeah, so we'll divide each of those by 2, and we'll reduce, right? So 3 over 2 we can't reduce, but 2 over 2 we can. That's 1, good. No, we're gonna slide the denominator up, good. So the 2 is gonna go up there. We get 2x minus 3, and this one we don't change because there's no denominator. So that's our answer. Ah, okay, there you go. Yeah, so now we're done. And how can we check it? Not plug it in. Foil it out, right? If I multiply this whole thing out, I should get this. And you can already see, sometimes people want to put that 2 up front, but you don't need to. Because look, when I distribute, what's 2x times x? There's my 2x squared, right? Okay? And et cetera, et cetera. We could keep going and it'll work. Okay? What about this? Convert this to vertex form. Okay, these, don't make these harder than they are, right? We're starting. Yeah, exactly. Look, it gives you the template right there. What are you gonna try to do to this? Okay, good. And the whole point is you want to be able to plug numbers in for A, H, and K, and that's all we want to do, right? We need to know what are the values of those parameters. So, right, and where are we starting? Well, this is, what form is this in? Standard, yeah, that's in ax squared plus bx plus c form. So what's A? What's B? What's C? Not that we really need C, right? Well, look, we already have A. A's 2, right? So we already have that. We got to find H and K. So you already told me my formula for H is, what was it, Dominic? Good. Okay, so if we plug those in, negative B, negative 4 over 2 times 2. That's negative 4 over 4. What's that? Aha. So negative 1 goes in for H. Got it. Okay, how do I find K? There you go. So I'm just plugging the negative 1 in for x. So it's f of h, which is f of negative 1. Well, there's my function, right? So that's going to equal 2 times x squared. I'll leave open parentheses to dump in the value, plus 4 times x plus 3. And the x value I'm plugging in is just negative 1, right? We got to simplify. I'm going to use PEMDAS though, so I've gotta do exponents before multiplication, so -1 squared is times 2, minus 4 plus 3, what's that? 1. Right, so then when I plug all that stuff in, what do I get? 2 times x minus, it's gonna be plus, isn't it? I'm gonna subtract -1, which makes it a +1 squared, plus 1, and there's our answer. Okay, no big, right. Okay, what about this? Now, we wanna find all real solutions. Now, this is stuff we talked about yesterday. We didn't really get to too many of these yesterday though, right? Okay, so we're gonna, yeah, exactly. And why is this easy? What's our strategy? Finding x, right? We can isolate x. Look, I can point to a single x, so we can isolate it by using inverse operations, right? So we'll just write down PEMDAS, and we're going backwards, right? Inverse operations. So first we add, subtract. What's that mean? Okay, good. So that's gonna give us 5x squared equals 121. Now what?
About 5.
Divide by 5, so step 2, dividing by 5, right? And that's gonna give us x squared equals 121 over 5. Ah, okay, square root, okay, undo the exponent, so I'm square rooting. That cancels the x squared and gives me an x. Now, we talked about this yesterday. What do I immediately write down if I'm square rooting something to solve it? Plus or minus, good job, kids, we need our plus or minus. And then we gotta simplify this radical result, right? Okay, so let's talk about that now. What are our steps there? Okay, good. First, we wanna see if we can reduce the fraction, but we can't, right? So then we split it up into separate square roots on the top and the bottom, which makes things a little bit easier. Then we want to make those as easy as we can. We want to simplify the top and the bottom if possible. Well, the bottom I'm stuck with. There's no couples there, right?
11.
But the top is 11. Okay, so I get 11 over the square root of 5. But look, I've got,
That's the basement. Can't have that.
got no tens. Can't have that. What do we do?
Do the thing.
That's supposed to say no tens. No tens in the basement, right? Can't have radicals in the denominator. No, we can't square it, because that's gonna change the answer. Multiply top and bottom by radical 5. That's our trick. Whatever's stuck on the bottom, if we multiply it by itself, it's like squaring it, so it undoes the radical, right? So we end up with, on the bottom, I get a 5, right? The square root of 5 times the square root of 5 is 5. 11 times the square root of 5, there's nothing I can do to simplify that, right? So there's our answer. So we end up with plus or minus 11 radical 5 over 5. Now, in Moodle, remember that, and here's a common mistake people make on these, they forget the plus or minus. In Moodle, it says separate all your answers with a comma, right? So we would do 11 radical 5 over 5, comma, negative 11 radical 5 over 5. Okay? All right, last one. Oh, this is just another one of these. Okay, but we could do something before we even launch into this. We could reduce the fraction, couldn't we? There you go. So we could make that the square root of 5 over 13. Now, we'll break it up. Neither of them could be reduced, but we got a tent in the basement. So what do we do? There you go. Okay, which is gonna give us, on the bottom, we're gonna get 13. So good, no, 10's gone, right? On the top, I get the square root of 5 times the square root of 13, which is the square root of 5 times 13, which is 65. Could we simplify that? Well, no, we can't, because if I make a factor tree, what are the products that make 65? 5 times 13. Okay, well, the only factors of 65 are 5 and 13 are both prime. So there's no couples. We're stuck with that then. So in this case, that's our answer, right?
Would that be plus or minus?
No, it's not. This one's not plus or minus because we're just simplifying a radical. We're not solving an equation. The step where we get the plus or minus is when we square root both sides of an equation. There you go, right, so you have an x equals plus or minus, okay? All right, good. You guys can work, get questions answered.
What's the password of the test?
Password is CV20. If you're testing, just flip your desk around.